Right then. Hello, and welcome back to the second session of the Tortus AI Academy. I am Dr. Don Pimenta. I'm CEO and co-founder of Tortus. I was going to be joined by a colleague and advisor, Sarah Gabauer, who's an anesthesiologist in the US, but as you can also appreciate, she's on the West Coast, it's super early, and she sent her apologies today, but hopefully she might be able to join us for the panel session at the end. For those of you who are joining us for the very first time, the purpose of the AI Academy is really designed for NHS leaders, CXOs and digital healthcare leaders to better understand the AI landscape. It's an evolving landscape. We're making senior decisions all the time, but the technology is new. And actually, as you'll see today, a lot of how we make decisions in this space is also a new and evolving science. This is the program. So if you didn't catch the first webinar at the middle of December, there's a wiki. I'll share the link at the end. You can watch the video back if you'd like to. That covered the basics. So some of what we'll talk about today, we have talked about previously, and I won't be revisiting those terms specifically unless asked. And here we are. I'm joined by Sarah. Hi, Sarah. Hi, how are you?
Hi, apologies. I was in the meeting, but wasn't sure how to actually join the stage. So thanks so much for having me. I'm so happy to be here.
Yeah, no problem. Well, I'll give over to you. I did a little bit of intro, but yeah, Sarah, love to get your intro here.
I'm an anesthesiologist and palliative care physician in the United States, and have an AI background, and do a lot of AI model evaluation work in different fields, including healthcare.
Yeah, awesome. So I'm just giving an overview of where we've gone up to. So today we'll be doing how to evaluate AI in healthcare. And I think maybe just for the tech purposes, I'll run your slides for you, Sarah, and you could just talk over them. Unless you can see them, I actually have no idea how it works. But I don't mind being the mouse monkey. And then what we'll do at the end, we'll have a little panel discussion between the two of us, some relevant topics, and good to dig into your experience a bit in the US, which is slightly, well, about 18 months maybe ahead of us in some capacity of deploying AI over there. So that'll be a super useful perspective. But also, you know, your other roles at the RAND, and we'll cover some of that. And then just looking ahead, so in 2 weeks' time, we'll be looking at clinical risk, be joined by one of our clinicians here at Tortus, and we'll do a bit of a more clinical safety session and the regs here in the UK and the medical device regulations. Beginning of Feb, looking at adoption with my colleague, Dr. Dave Trisker, and how we get stuff into the hands of people, the trust gap, the credibility gap, the implementation gaps, and what training really is. And it's actually a bit more complicated than we think. And then a bit of a fun session planned for February with what clinical lead here, Dr. Josh O'Young, what the future can hold. And for that, we might actually try and get a bit of a bigger panel, but you know, time will tell. So without further ado then, let's see. Yes, and just to reiterate, so the point of this course is to learn how to buy AI for healthcare wisely. It's not a computer science class, so although we will touch on some basic principles, we won't be diving into them. We won't necessarily be diving deep into how the models fundamentally work, the mathematics, the latest advancements. It's very much about what is the market today, how do we utilize, how do we get to a level of understanding that's useful, and to make wise decisions in the best interests fundamentally of our patients. So ideally from concept to clinic. Yeah, and at that point, I'll hand over to Sarah. Sarah, take it away.
Great, thank you. And for those in the audience, I would really welcome questions, and I'm really excited to hear about your experiences in this area, and how you think things should be different or could be better for you as clinicians. So in terms of what we want to talk about today, we'll talk about why AI models need different kinds of metrics. So we're all used to metrics in medicine, for better or worse. That's been a focus of the last 20 years or so, especially since the adoption of EHRs. So why are AI models different? Why do we even need a specific session to cover this? The meaning behind the metrics, there's a lot of uncertainty right now about what it means to have a good AI platform. So what does that actually mean clinically? What does that actually mean in comparison to the current standard? And what should we be looking for? And then really focusing on key questions that you can ask people who are either trying to sell you something or that might be discussed during adoption of a clinical AI application. Because I think there's a lot of noise out there in terms of what people might try to tell you that may or may not actually be applicable to what you need to know. Next slide. So as you guys talked about last time, does anyone want to put in the chat, can anyone remember the difference between the probabilistic and deterministic approaches to models?
Let's have a
see who can get it in there.
Anyone's brave enough to answer that question. So you'll find the chat on the bottom right-hand corner of the platform. So yeah, anyone want to take that question?
And this can be kind of a general question of how is AI, in terms of how it makes its decisions or how it creates its outputs, how it's different than other platforms that you might have used in the EHR and other places.
Oh yeah, very good. So Parag says same input equals same output versus an element of randomness. I think that's a pretty good.
Yeah, that's a nice summary. So that some people will say the word stochastic, meaning that it will try an output and see if some percentage of the time and try a different output some other percentage of the time. So you might hear that word as well. And obviously that's different than a lot of the tools we have, which are very rule-based. So what we use right now a lot of times is, if this, if X and Y. And that is not how AI systems work. So when you're evaluating them, there is that same randomness, which creates, can make it great in terms of creating different kinds of outputs and being able to be more creative. Also brings up some questions in terms of if you're going to, if you imagine a factory, you're putting in the same thing and then possibly getting out different outputs or different probabilities every time. So it makes it a little more challenging in terms of determining how many tests you have to do, for example, to show that how often the right answer might occur.
We have a few more answers in the chat here. So Vitor says a deterministic system has predictable outcomes, while a probabilistic system involves randomness and uncertainty. Also pretty good. And Claire said trained or learning, not quite, and we'll go back to that. And then Omar says basis for answer, guided by rules or policies or just reasoned. That's interesting, isn't it? I guess maybe that's similar to what you were saying about workflows and deterministic versus probabilistic in that sort of sense.
Yeah, and I think it is interesting because a lot of the AI systems do use the rule-based systems in terms of policies and guidelines that we have in order to inform themselves about what should happen next, but they still do have that element of stochasticity or probabilistic thinking, if we want to use that word, as they work. Yeah, okay, so we got some great answers in here. Wonderful. But we can see how that would cause a problem for model evaluation. So it can vary on the context. So that context could mean kind of patient that you have. It can mean the setting, whether you're in the ER, are you in a clinic setting, and there's a lot of aspects of things like bias, and then the training set. So and whether that reflects your patient population. So just because it's been evaluated in one context with one patient population or in one setting, that doesn't necessarily translate into another setting. And we know that just intuitively as clinicians, a lot of things we do, a lot of things I do would be, basically useless as an anesthesiologist if I were to be in a clinic without the tools that I usually have, for example. But especially when we're talking about things like bias that we're worried about not having the kind of data to accurately represent people and their conditions, then we get more and more concerned about knowing how often we need to run the tests to be sure that they have a kind of output that we can at least trust in a basic sense. Yes, things like psychiatry. Yes, you are used to some randomness probably in that field too. And then the other issue is model drift. So this is a well-known phenomenon within AI in which the performance of the AI models changes over time. Often they'll be the point of them often is to kind of learn from the data that they're presented with and the decisions that people make based on that, or the not so much question and answer pairs, but the input and then the next steps from that. And that can be great because it can inform the model and provide it a way to give even better output. But then it can also stray away from its original setting. And so there was this recent paper people might have seen looking at chest x-rays, and the authors asked, does this check which of these patients eats refried beans the most often and then drinks beer most often? And the models provided answers because they had learned about things like demographic patterns in other parts of their training in terms of what areas of the country were most likely to eat refried beans and drink beer, what kinds of people are most likely to do that. And while that's a slightly different concept, you can see how as you put in more information into a system that may or may not be relevant, how it may then infer different answers to the same questions over time. Don, feel free to pop in if you have any comments.
Yeah, I was going to say, like, who eats refried beans in the UK? No one. maybe a burrito here and there, but nobody here. So if you trained it here, it'd be like 0. We don't eat that.
Probably a wise decision, right? Exactly. So this means that you can't just do one evaluation for an AI model in most cases. You really need to be continuously monitoring these systems. And really, this is something that we should have been doing probably always with any kind of IT product that we have, not because of this model drift situation, but more because practice patterns change, workflows change, and we really should be seeing, making sure that the technology we're using is still relevant and helpful, at different periods that we use it. But in AI, there's this additional layer of making sure that the model hasn't drifted away from its primary purpose and from its primary outputs in terms of the metrics for accuracy and the metrics for bias and things like that we're concerned about.
Yeah, and I would just double down on that. Actually, with some of our partners, we have an evolving technology test. So every 3 months, we'll look at the LLM quality and the outputs, and we make a lot of changes much more rapidly than that as a startup. So we kind of have to do that. But it's interesting what you said about the workflow changes, because obviously, not obviously at all, but if you're going to have a probabilistic model where you have a fixed input and the output changes over time, if the input starts to change over time as well because the workflows change, I'm just thinking like maybe the letter type is different or the summary ingestion is different, then actually the output will also change. So it's like constantly looking back and seeing what we're doing and maybe building that into the system is also a requirement for AI specifically. But I love your point about we don't do this for any other tech. And maybe I could think of so many things that are broken because they don't work like they were supposed to because we put it in 10 years ago. Lots of EHR functions being one of them. And we never look back and see, is that safe? Is that testing? So yeah, I agree 100%. There's a wider principle here that probably goes, beyond AI.
Right, and this might be a way for AI, for places like Tortus and others who do this kind of more frequent testing, to be able to provide some leadership and say, no, this is really what should be happening for everyone. And then one other point that's related is a lot of times you'll get results from testing. For example, the Hippocratic AI group has done a really great job doing a lot of safety testing on their product, but they've been changing the model as they've been testing, and therefore the results that they provide are not necessarily the results of the current model, which I think is something, it's a subtle point, but it is important, especially when we talk about this model drift and how AI models change over time. So there's this natural drift that happens as the inputs change or as the models change themselves, but then there's also this kind of artificial drift in which the developers change the model as it's going on too, and so the evaluation of models that they did, 9,000 patients ago might not be relevant for the 1,000 that they just did and just reported as a 10,000 person set, for example.
Yeah, I mean, we see the same problem with third-party vendors. So if you if you're using and evaluating a company that's hitting, even if they're very clear, like we use this third-party cloud service, that third-party cloud system is also updating its model pretty regularly. And if the vendor, when you're talking to them, doesn't know exactly which instance of that model that they're hitting, and it's not locked to that dated instance as opposed to the evolving model, then actually the performance will change over time. So it's almost like, what pre-evaluation metrics are we actually testing? But then post, is that still valid? And actually, is there even something the vendor's monitoring? And I think that's another, like, who's watching the watchman in that sense? Like, what is the evaluating of the evaluators, and how much reliable? And that's again about instilling knowledge across the whole procurement spectrum, from the patient, but all the way back maybe to the cloud provider, because actually we need to figure out what actually is happening in a very rigorous way, which we haven't had to probably do before.
Yeah, I totally agree. So this is a graphic of some U.S. Quality metrics that we have to report. Some are for cardiology, Dom's cardiologist, and some are for anesthesiologists. And so you can see that, if I tried to report these cardiology metrics, that would be completely useless, and vice versa for Dom. And so in the same way, we need to have different kinds of AI models, different metrics for different kinds of AI models. So this is intuitive for most physicians. Most physicians really understand this because we already do this very regularly for our own specialties.
Yeah, and it's interesting because I've added some sort of a local flavor there. So we have different metrics for primary care. We have different metrics for surgery. We have national audits, national registers. I mean, you have the same thing. And then we have tariffs and individual audits for what people care about. And it's interesting because, like, even evaluating the metrics when we're talking about the same AI system, but in different settings, the metric that we care about in A&E, for example, for a scribe, is not the metric that we care about in primary care. It's a completely different, the value of what the actual chain is really, really different. And also the quality and the time spent, again, psychiatry may be very different to, the ambulance service, for example. So that's another really important thing, is like the evaluation needs to be dependent on the use case. And I think, yeah, super good. I didn't clock actually that these are so different, but it's interesting that you have to report prevention of post-op nausea and vomiting. That's an interesting metric, a granular detail into the US system, and maybe we can get into another session, I guess.
Yes, they are very big into granular detail about these metrics. And so for ambient scribes, we talk about metrics related to accuracy for the transcription itself. Are the words being captured accurate? And then note organization. So once the transcription is made, is the note organized in a way that people can read it and that's meaningful? And then isn't fluent. So is it, if the sentence is choppy, is it hard to read? Or is it something that, flows really nicely and that people actually want to read? Whereas things like diagnostic prediction, we want to know about things like, can this identify patients who are at high risk for this kind of condition? Are the clinicians adhering to appropriate guidelines, or can the diagnostic prediction algorithm help them do that for certain patient populations? What's the sensitivity and specificity of the prediction model? And so these are really different kinds of metrics that are measured in different ways and reported in different ways, and that mean different things. And that really are captured at different points in the process. So you can see how very quickly, these are just two very basic examples of technology that we're getting to know better and better, and that already have good baselines in medicine itself. So we already know a lot about how accurate physician notes are, and general clinician notes, which is like really terribly, is about half of notes, and at least in the United States, up to 80% have information that can't be verified, and about half of it is inaccurate. Between 50 and 70% is copy and pasted, and then in terms of note organization, we have data about how well residents do that versus medical students versus attendings and that kind of thing. We interestingly have in the United States mostly switched to an assessment and plan up top, acknowledging that basically no one reads the subjective and objective portions of the exam, and straight to the point. So those are have been flipped relatively recently. And then fluency obviously is something that can be measured pretty well in an AI context, just because that's such a strength of AI in general, is creating generative AI is creating words and text. And then, for the diagnostic prediction, that's something we've been trying to do for a long time in medicine also. And so I just mentioned those because it's nice when we have some baselines of knowing how well we already do things in medicine. There are starting to be, and there will be more cases in AI in which we don't have that kind of clear baseline. We don't know how well we do at things already. And those are even harder to compare. So, we know with ambient scribes that almost anything is better than a human because, very unlikely to, and even dictation is, 24% of dictations have some kind of inaccuracy that includes the clinical part of it. So this is only going to get more complicated as things as the technology improves and the use cases proliferate.
Yeah, and I think what's really interesting about putting these up side by side is I was thinking about bias. So over here on the diagnostic deterministic side, bias has a really clear statistical meaning, like a mathematical meaning. And then we also have the term in the healthcare sector wider about bias, and we really care about, how are you treating your diverse populations, how are you systematically treating them from a human perspective. And then we introduce large language model bias, and we ask that question, and actually kind of could mean both. Like, how does it deal with accents? That's one version of bias. But actually there's a statistical element which doesn't make a lot of sense for probabilistic models. So we often ask questions like, how do you deal with bias on the large language model side? I was like, well, what do you actually mean? And then the answer we often get is, oh, we're not actually sure. And this is the problem that we have back and forth. And again, it's about definition. So maybe there is an argument to say, as the metrics get better, we develop at least more defined or more clear frameworks, and maybe redefine some of these terms which are now becoming multi-plural. One word means three things in the same setting with patient impact. That's not a very great situation to be in, and I'm sure there'll be loads more as AI becomes more and more part of our day-to-day and takes over more of the human element.
Those are really interesting points. That the human bias piece is actually really interesting too, because we also have baseline data for that, which is also that clinicians tend to include quite a bit of bias in their notes at baseline as well. So there are a lot of parts of these things that I think people think humans do a good job at that has been shown to really not be the case.
Yeah, and I think that's interesting, isn't it? Because now we have to study this stuff. And I think we'll come on to that. But like the studying what humans are doing is probably something we should have been doing, but weren't doing because there was very little point. But suddenly we're like, oh, maybe the AI could do that, or maybe the AI shouldn't do that. But what is the performance metric that we're trying to beat? And I think we don't understand that at all for large parts of the system we have today.
Exactly. So we kind of talked about this some in terms of the bias and what bias means in different kinds of settings, and then when it's more important versus less important, and it can have really a range of meanings. So this is going to be an answers in the chat question. So say you're listening to a presentation and someone says our ambient scribe is 90% accurate. What do they mean by that? Just what is your first thought? What have people told you when they've talked to you about their products?
Omer's come straight in with BS. Obviously, this is a 1 o'clock showing, so we can all intimate what he means by that. But that is also my first thought. And mostly, I was an academic before I got into this, and I would sit at a lot of meetings and I'd hear that word accurate a lot. And my first question was always be, what do you mean? How have you measured that? What metrics have you used to do that? Parag says 10% of information is wrong. That actually sounds quite worrying when you put it like that. Accurate, so misses the point. Steve says, my first thought is they don't have a beautifully attractive product. That's a very cynical. I like this British cynicism here. I think we're really showing up for the country right now. Correct, 9 out of 10. 90% is good. 10% is a lot of work. Arbitrary number. 90% accurate would not be good enough, as Parag says. I mean, it's actually really interesting, isn't it? A, the breadth and diversity of how we're interpreting that. B, the cynicism. But C, I think the question no one's asking, which is the only question, is like, well, how accurate is the human? And I think that's what we've just been talking about, because if it's at 90% accurate by the same metric, but humans are 60%, then it's a done deal, right? And we should be iterating from there. What else? 90% of what, of whom? Yeah, that's very valid. Definitely looking at that. It's pretty meaningless. Yeah, I think Stuart hits it nicely. It's pretty meaningless, and I think without the hard data behind it of what the situation is and what it means. Accent clinic specifically, and
right.
James is asking, how do you get to 100? Maybe that is the optimal question. Actually, it doesn't matter where you start, as from an AI perspective. But what are you going to improve about the system that gets you? And then that obviously tells you how they've measured it. Yeah, that's really good answers here.
So if we go through, if we click through the slides, we'll have some possibilities of things that I have seen people mean when they say this kind of thing. Right, to 100. Do we get to 100% even in conversations? Yeah, I've been married for 16 years, and I can tell you a lot of times no with my own husband. So, that's a great point. Despite everyone trying their best. So I've seen this mean how many words are captured from the conversation in the transcription itself. So kind of more like an ASR, speech recognition metric. How much of the important transcription is included into the note, how often hallucinations occurred or didn't occur, the percentage of clinicians who would write the same note given that transcript or given that information, the percentage of medical terminology that was used correctly, the percent of clinicians who used it who thought the note was accurate, who used the technology and then thought that the note that they were provided was accurate, and then how much even the patient agrees with the note is something that I've seen. So any of those, and I'm sure there are probably another 20 possible meanings to this one relatively simple seeming question. So I think all of you had a great first instinct, which was to mostly disregard this as being meaningful. But I think there is an important point in terms of you do want to be talking to people who are measuring something, and knowing what to measure is hard. They're not going to have every single answer to every single kind of metric you probably want at their fingertips. But I think what they're measuring will probably tell you a lot about, and how they're measuring it will probably tell you a lot about them. So there's this dichotomy within the AI metric world in healthcare, in which any study by clinicians tends to have to use the PDQI-9 scale, which is a subjective view of physicians reading the note, and they rate it on a 1 to 5 or 1 to 50 Likert scale, basically. Whereas if you look at all the AI literature, if an AI person does basically the same study, they run metrics like Blue and Bluert, and these more quantitative accuracy metrics, the same kind of data. And so you'll see both of those reported, and they mean really different things in terms of your clinical needs also.
Yeah, I mean, this is a science that we've been working on at Tortus for about 2 years. And one of the things that we had to do very early on is figure out something, because we didn't know how to make any decisions about which models to choose, or how we were getting better at prompting, worse at prompting, like any of these metrics. So we ended up actually somewhere in between those two, of saying, well, what is the task? Delineate it to clinical entities in the transcript, delineate it to clinical entities in the note. If they're they're present, they should be present, that's a true positive. If they're not present and they shouldn't be present, that's an infinite space, but that is your true negative. And then your precision score is your false positive. So of the percentage of clinical entities, how many are made up? That's your hallucination rate. And then your omission score, or your recall, is going to be how many clinical entities are missing from the note, from the transcript. Great idea. And as soon as we launched it, like, hallucinations pretty much make sense, right? But there's some subtlety with inference and externals and internal, and there's whole papers written about that. Most of the nomenclature in the AI world is just kind of a bit nonsensy around that. But omissions is really hard. And you've nailed it here as well. Like, what is the important transcription? But what's important to me as a cardiologist, is it important to the dietitian, and vice versa? And in fact, we've had some feedback. The dietitians are using the system and saying, well, it never writes down the flavor of crisps the patient likes. And I can laugh about that as a, I just care about the salt content, right, as a cardiologist. But the flavor is so important because that's something that they can eat. They can eat meaningfully, and they have to buy that specific thing to get their weight or their nutritional status up or whatever. So like that's extremely subjective, and I still don't really know how we score that, other than it's relative and it's getting better. And then there's this medical legal question of, okay, the recall isn't great for this, this situation, but it's subjective, and you've made a choice that in your AI system you don't want that data in because it's not relevant to your specialty. But can any vendor actually make that decision? I don't have any answers to these questions, by the way. I'm just like going through some of the issues that we've had. But yeah, it's actually quite a fascinating problem in that sense.
I agree, and there are some really great comments in the chats. Yes, the semantic similarity. These AI metrics do focus on semantic similarity rather than meaning. There are advantages and disadvantages to both ways to look at these metrics. Probably some combination is likely most meaningful for clinicians. And then yes, contextualization is just so important for clinicians, especially to be able to make good decisions. So gold standards. So what is the gold standard for a good AI product? How do you know if you're getting a good one? Does anyone have a way that they decide this? I'm curious. I mean, I think it's a really hard question, and one that I think is, especially as clinicians, we often have to advocate for a specific technology or for a specific way of doing things, especially if it's expensive and changes the workflow. And so we need to be able to say, this is, best in task. This is, this will do something that I really want it to do for some reason that will probably, and we'll, you'll probably end up saying something about saving money in there because you'll be talking to someone who holds a budget. So here are some things that I have heard people say for this is what the gold standard should be. So, and you can see this is great in the chat. There's a huge range. So it's everything from no hallucinations to allowing me to focus on tasks that I prefer, reliably performs its stated function. No critical errors is one that I hear a lot. So not likely to kill someone is kind of the bar, which is, probably a higher bar than we have for interns a lot of times, frankly, but, first year doctors, but, we do our best. And then, or is it that you do as a physician, you together with the AI system do better than you would have done otherwise? So is it a completely just machine issue, or is it a physician or clinician, human plus AI improvement as what you're really looking for?
It's really interesting. I think actually Lorna's hit the nail on the head for me. It's a reliability. I think when we first started out, the idea, like we had this whole list of like accuracy, and I mean, we certainly do aim for all of this as a quality product. But I think the fundamental is like any technology, if the closer you can get to something repeatable, the better you can iterate upon it. And the more you can mitigate for risk if you understand that it's going to perform day in and day out at the same capability. Because even if it's worse than the human, you can make it better as soon as you get to that iterable state. And actually, like most things in medicine, it's like the boring stuff done well, but every day is so key to a quality product that's sustainable. Whereas actually, a product that saves you a bunch of time, but only one task in 20, we all know we're going to get rid of after the second task, right? So it's interesting how, on reflection, I think, something that works pretty much the same way every single time in a very simple but very reliable way would all be actually in my top 3, I think I would say, in terms of quality for metrics.
I agree. And just checking the time, I think we only have about 9 minutes left. Is that right?
Yeah, we've still been doing some question and answer as we go, right? So yeah, but we can, I think we haven't got a few mini slides left.
So we call this thing when we compare the computer to the human baselining, but that also is an evolving science. And then so there's this, there are all these kind of science of evaluations questions that have yet to be answered in any field in terms of how many humans is enough? What if do you want an expert? Do you want a non-expert? Do you want a mix of those two? What if the experts disagree or have really varied performance on tasks? One thing we see a lot is that AI systems have a lot of have a wide breadth of domain expertise, whereas humans tend to have one very deep area of expertise. And so when you say we're going to compare this product to human performance, you often then have to, if you're going to do it well, you kind of have to find, maybe 5 or 6 experts who evaluate different sections of the AI, because there's no one person who has that entire breadth of knowledge. And then things like, were the human experts, if you're having them take a multiple choice test, for example, to compare knowledge between humans and the AI systems, were the humans given money by the number of questions they completed, or were they given money by the number of questions they got right?
Yeah,
so even things like that can make a difference in terms of what you expect for humans, and therefore what that context would be for what you would expect for the AI systems. So I took this from one of the ambient scribe systems, which I mostly thought was funny because it said unmatched outcomes. And I was kind of like, well, that's because no one really wants to match these, because these are silly outcomes to have. But so the the time saved per clinician, that's important. But a lot of these, as you can see, are not, they're very subjective metrics based on how the clinicians or the patients felt about the technology. And there really are not any, it says that the clinicians believe it improves documentation quality, but not that it actually improves documentation quality. So you'll see a lot of these kind of metrics out there, and I know this is an especially savvy group, and I'm feel confident that none of you would be unduly swayed by this particular set of numbers. But I think a lot of people see numbers above 70% and are like, well, it must be pretty good, and kind of move on. Or their administrators may be more impressed by this than some of the clinicians would be. So I think part of, as we're all learning, all of us are learning together how to do these kind of evaluations, and what's important and what's meaningful. But the questions that you guys identified in the chat, like, where is this number coming from? How many tests have you run to show that it's that this number is accurate? What are you going to do on an ongoing basis, as Dom mentioned, not just for monitoring your product, but monitoring how your product interacts with other systems. And I would also note that that's not just confined to a system that is related specifically to your product. There have been some studies showing that when more than one AI system interact, that the performance of both of them decreases. And that I expect will be a growing area of evaluation as well, that really is so nascent that it hasn't even started yet. And then why, for that company, I think it's really important to understand in terms of their values and how rigorously they think about evaluating their products. Why did they think that these were the most important things to measure? And why did they feel like that's what they wanted to put resources towards? And I think that'll give you some information about what you can expect from them going forward as well, in terms of where they're going to focus, and how well they plan to continue to look at metrics even after the product is sold, because that is going to be a big part of you relying on them to provide ongoing support. So I agree. I don't think they're meaningless. I shouldn't have said meaningless. I should say that in the context in which they were studied, I don't think it's super meaningful. But in a real life setting, those could definitely be more meaningful. Yes, you're not going to get any tech. I agree. You're not going to get any technology anywhere unless people actually like it and are using it. That is, you are absolutely right. And yes, intra and inter observer calculations are really important, and I'm not sure those are being done anywhere that I have seen so far.
Yeah, especially for subjective measures, we're quite bad at that, I think. A few more questions here that you've got for key questions. It's a different slide, sorry. It looks very similar.
Yeah. So then, kind of similarly, how did you determine what was a reasonable performance standard? Did you compare it to humans? Did you compare it to perfection? Did you compare it to the current computer system that's being used, the human baseline, and then what's the human-computer interaction, which I also expect to be a growing area of research in the coming years. So, how this may, and this has been shown multiple times too with AI systems, is it works great by itself, and then once you put a human with it, it just doesn't have any impact.
Yeah. I think we've seen that as well as like recommendation systems where the human doctor is wrong, but also ignores the AI, and it's like, well, what was the output?
Right.
Great. That's the end of our slides. So we'll come on to the quiz section. So we've got a little bit of a quiz that we have prepared. So you should be able to see it in the polls section. I'll just push them live as we go. So the first question is, model drift describes, let's see how well the audience were listening, how AI model performance changes over time, the use of inappropriate data in training, or C, Kim Kardashian on a raft. So let's see how people are voting for that. Can I see the result? Okay, 100% of people are going for AI model performance over time. One person is in a good mood today and thinking it's Kim Kardashian. I think most people have got that. And I think not just even the model, but increasingly the system. So one thing that we also haven't talked about is how do you evaluate increasingly multi-model systems, multiple models doing multiple things, multiple different workflows. And I think increasingly that might actually become an outcomes-based assessment as opposed to each individual model in the system, because it will probably be impossible and potentially very difficult. Okay, next question then. Very good. Describing accuracy. Hold on, let me publish it first. Describing accuracy for AI systems is A, an evolving science, B, variable depending on the vendor, or C, all of the above. I'll let you guys have a little look at that. Variable. Yeah, it's a bit of a tricky one, but as you've seen, it's certainly all of the above. And I think could potentially go also variable depending on the buyer, right? Because how much you dig in, what your frameworks, what your expertise are to ask the right questions and to understand the answers. That's kind of the gap that this course is trying to address. But that will also change over time because the speed of technology is exponential. And how do we even start to understand these things, I think, is increasingly becoming very difficult. So very good. So the answer to that one was indeed all of the above. And last question then. So human baselining describes what? A human AI systems working together. B, determining current human performance of a task. Or C, base jumping straight off a cliff and instead of down. Yeah, great. Current human performance. I think this is really interesting. I mean, we did some human baselining of summarization of notes a long time ago. It was a super crude study. We did it basically over a weekend. But the idea was like, if you look at a bunch of letters and you write a summary based on that on the patient, which we all do every single day for every single patient we see, how good are we actually at that role? And the answer was awful. We're about the 6 errors for every 2 letters was what we saw. Whereas the AI model was 0. It's only 2 letters, so even with a small context window, you wouldn't expect it to make many errors at all. But that is a task we're repeating and compounding every single day. So you can increasingly see that this is going to be a bigger and bigger issue as we get into more AI systems. Well, fantastic. Thank you so much, Sarah, for that. Just a brief reminder of today's session. We'll send out a bunch of resources alongside it as well, so some extra material to have a read and have a think about. Understanding clinical risk in 2 weeks' time, and then driving adoption in clinical AI beginning of February at the next session. So we'll ask if there are any questions. We have a little bit of time left and we can run slightly late. Floor's open to the audience. Got a nice engaged audience today, 70 people. Do ask us any questions and we can see what comes out of it. There were some really interesting comments that maybe we didn't get to. I wanted to go back to the beginning actually. I
wanted to say that I'm happy to, if anyone has questions about evaluating a system or something, I'm happy to answer questions, happy for people to get in touch and and email me at any time. I know this can be a really overwhelming thing to try to do, especially if you're trying to integrate it into a hospital and talk to other people about it. People get very confused very quickly. So I'm happy to talk through that with anyone if helpful.
Yeah, no, for sure. I've just added the wiki there as well for the previous session, so it's an open site. Anyone should be able to access it and have a look. And it's got the first session, and we'll upload this video hopefully a bit later today. Any questions from the audience? We went through quite a lot as we went. There was some really interesting stuff, so I actually wanted to go back through. So there was a comment about deterministic always being accurate. And I think it's interesting because the best way of thinking about it is like it's going to be wrong, but predictably wrong in a way that you can measure and rely on, as a probabilistic is a bit more variable. Is that a fair characterization, do you think?
I think so. I'd be interested in hearing others' thoughts. It puts me in mind of the picture you always see with target and accuracy, and it can be off the mark, but reliably hits the same place off the mark over and over. And I think that's probably a good visual.
Actually, I did have a question for you, Sarah. So when you see a new AI vendor who comes to you in your clinical practice, do you have like one killer question that's like really sorts the wheat from the chaff in that sense?
I think the main thing I look at is the metrics that they present, and if they can explain them well. I am very impressed. That happens honestly pretty rarely, and part of that is because often we're dealing with salespeople and not the data people, and so there is usually some kind of disconnect there that's a little harder for some of these companies to bridge on a regular basis. But I'm hoping that as this matures, that there'll be a better understanding. I did want to also piggyback off your comment about the multi-system interactions. So I think there's that, and there's also these, soon a lot of this will be agentic. So there'll be a model that's using that's used not just interacting with, but actually using other models, and there'll be multi-agent models. And those are even more complicated in terms of measuring them, but just something for the audience to think about as they move forward, that these models are going to start to be able to use tools, to use the internet, to use the EHRs more reliably and things like that. And I think understanding these questions, you guys are so far ahead of your peers already in terms of, just I can tell by the questions you're asking that you guys are really well positioned to educate your peers, and you're probably going to need to be in that role.
Yeah, the chief AI officer, we're seeing the rise of that in the US certainly. And Omar asked, "What is AI anyway?" That was the previous session, Omar. You can check that out. It's a good one. I had another question for you, but actually Omar's like throwing me off there. I think what's really interesting with the tools is we often see. And you've seen this before. Like there was a lawyer that was struck off because they were using GPT-4 to write their cases for them, without realizing that it's not a knowledge summary. It doesn't have knowledge embedded in it. So, like when we start bringing things like guidelines or like sources of knowledge, which some of the models are starting to do now, and we'll definitely see that this year for sure. How do we start thinking about that? Because then it's a two layers. Like, is the knowledge source good? And is the model interpreting it in the right way and missing? And that's much more of an autonomous task. Do you have any thoughts on how we're going to start dealing with those kind of evaluations?
Yeah, I mean, I think we're going to need to, I think in some ways these are getting more and more similar to evaluations that we do of humans, because humans also do a lot of kinds of tasks and use a lot of kinds of tools along the way. So clinical validations focus more on outcomes and less on process. So probably you just kind of have to look at, does this help on things that are meaningful to clinicians? Because you can't look at the more process-based outcomes like the transcription accuracy and things like that anymore, when you have so many different variables that could affect the end result.
Pipeline's much more thing. And if there's no more questions from the audience, I've got one other question, which is, we talked about this before. I think the one thing, we vaguely mentioned it a little bit, but it's about the human AI interaction. and not even necessarily like the impact of like the physical buttons or the time spent on the computer, but what does it do to our brains? And I was thinking about this a lot a couple of months ago because someone said to me, Dom, you're not communicating as clear as you normally do. And I was like, well, why is this? And I realized that I'd been using AI to do a lot of 0 to 1 thinking. I'd be like, oh, what should I think about this? And then it gives me an answer when I was editing it. And I realized I'd lost a bit of capacity cognitively to sort of do that. It seemed a bit extra hard, the muscle wasn't as strong. But I do wonder, like when we have AI suggesting things, for example, or I have AI pulling up guidelines, does that influence our decision making? Is that, there's like another portion of that, which is like the human AI pair. I have no idea how we would begin to evaluate that. I don't know if you've had any thoughts around that.
Yeah, I mean, there is some interesting data from radiology, from the vision-based fields, just because they're so far ahead of a lot of the other AI-based, generative AI-based fields. And there definitely is evidence that if you present the answer from the AI first, the humans turn off their brains and just go with whatever the AI says. And if you present it too far after someone has kind of already decided that this is what's happening, they just completely disregard it, as you mentioned. And that there's some sweet spot in terms of providing the information at the right time and at the right level to make a difference. But I don't think we have a real complete answer yet about when that is. You may be familiar with in the United States, because things are approved by the FDA as software as a medical device, and therefore they can be billed for. They read at the same time as the radiologist, and then if they see something the radiologist doesn't see, then they will say, we have detected something that, in here, but the radiologist doesn't always know what that is. So then they're kind of guessing, like, what might that be, and is it right or not, which is kind of a way to make somebody crazy, just by saying, something in there might be wrong, but I'm not sure. And so it ends up taking more time. And a lot of these systems are really put in place to save radiologists time and to increase speed of readings, and instead have either kept them the same or often increased how long they spend on each read. And so I think that's another place where the context has to come into play. How often are things meaningfully missed in radiology at baseline? And is the 2 to 5% of catches that the AI has been shown to provide for readers, is that actually clinically valuable? And I think the answer may be that it's maybe clinically valuable from 10 p.m. to 6 a.m. or something, when we know that people are fatigued and humans, naturally will make more mistakes. And so there may be some element of when the humans are known to be especially bad at something, that's when we include an AI co-pilot or an AI helper to really assist in those kinds of tasks or specific time periods.
Yeah, I remember doing my favorite sim training ever was human factor training. So it was like sort of resus situation, sim suite, but very much focused on. And I remember I really like it actually because it had some completely nuts scenarios. It had like a what's that poison gas? Sarin. It had a sarin gas attack as one of the simulations, and you had to figure it out. But I think what's really interesting here is maybe there's a gap already for AI factors or human AI factor training to think about how to interpret, when to interpret. I mean, the co-pilot analogy I was just thinking about as well. There's a really clear handoff who's flying the plane at any given moment. And there's a real bunch of safety. I'm going to give it over to the autopilot. It's going to come back to me. This is how I do it. The co-pilot's there. We haven't quite got there with the cognitive, but often, as clinicians, we're flying planes in the most true sense of the word, where we're trying to carry a human being through a process or through a journey. And if the AI is assisting us, but we haven't really thought about, who's making the decision or how, medical legally, that's a minefield already. But even just practically, will we de-skill a whole generation before they even have a chance to learn how to fly a plane in the clinician sense? I think that's also something we need to really think about. We are at time and slightly over time. So I will thank the audience. Thank you so much for your time. I thank you, Sarah, for, I don't know what time it is there, but it's super early, far earlier than most UK doctors would ever wake up. And it'd be lovely to follow up and have another chat. And maybe we come back to the panel in next month and we can have a further chat.
That'd be great. And yeah, look forward to keeping in touch with any participants who are interested in this. I love talking about this stuff, so I'm thrilled that Don was kind enough to invite me, because I could talk all day, and I think I've used up all the people that are also interested in this, that want to hear me talk about this.
Oh yeah, no, I was just thinking maybe we get a podcast going, but we'll talk about that offline. All right, well, thanks everyone, and I'll close it there. And, yeah, the slides will be available soon.
Thanks. All right, bye.